Hey everyone, let's look at the concept of game theory. And game theory is helpful in examining mutual interdependence and strategic behavior by oligopolists. Look at the elements of a game. There can be two or more players. Each player has a set of actions. The information available to all the players before taking or choosing any actions. In our example, we look at the prisoner's dilemma game where we have two players, Bonnie and Clyde, and each player has two possible actions, either to not confess or to confess committing the crime. And their actions are chosen simultaneously. That means they do not really know what the other player will choose when he or she chooses his or her actions, because they are definitely gonna be interrogated in two separate cells. Now we want to find the Nash equilibrium, which is an outcome from which neither rival wants to deviate. So we have this matrix which is called a payoff matrix. I'm just taking up everything because I want to explain from the beginning. And looks like we have four set of boxes. Each of these boxes are showing the actions of each player depending on the action of the other player. Clyde can choose to not confess or confess. Bonnie can choose to not confess or confess. The first number in each of these boxes is for the person on the left, who is Clyde, and the second number in each of these boxes is for the person on top, who is Bonnie. Now let me explain box 1. Is going to make things easier to is my laptop acting up, understand. So if Clyde chooses to not confess, he gets 1 year of jail time, and Bonnie chooses to not confess, she gets 1 year of jail time. The next box is Clyde chooses to not confess, getting 15 years of jail time. Bonnie choosing to confess, getting 0 years of jail time. So we can also explain box 3 and box 4 the same way. Now to solve this game, I'm going to take some column and a row approach. I will choose the first number in each of these boxes for each column, compare and choose the highest number. As for example, if I look at column 1, which says not confess by Bonnie, Clyde has a choice between -1 and 0. Because 0 is greater than -1, Clyde chooses to confess committing the crime. Now if I look at column 2, where Bonnie chooses to confess and Clyde has a choice between not confess and confess, Clyde will choose to confess over not confess. So choosing confess over not confess, no matter what Bonnie is doing, makes confess the dominant strategy for Clyde. So basically what you are doing here is comparing 0 and -1. Then you are choosing 0, comparing -15 and 5 and choosing -5. Let me make this easier and circle the numbers I just chose. Now look at row 1 and row 2. Row 1, Clyde chooses to not confess. Bonnie will choose to confess over not confess. Row 2, Clyde chooses to confess. Bonnie will choose to confess over not confess. Let me circle the chosen numbers. Looks like confess is also Bonnie's dominant strategy. So I have 2 circles in one of the boxes, and this is the solution or the Nash equilibrium of this game. Because we have only one Nash equilibrium or one solution to this game, we say this Nash equilibrium is unique. Number 2, is this -5 or 5 years of jail time efficient? My answer is no, because both of them can do better if neither of them chooses not to confess committing the crime. Even though this is a Nash equilibrium, this is unique, but this is not efficient because they could have basically done better if they chose to not confess either, but they did not have that choice because they did not know what the other person was gonna do. Okay. Now I'm gonna look at another game, which is a battle of sexes, which says husband prefers football game over shopping and wife prefers shopping over football game. Probably when this game was written, I think mobile phone services were not in use. Alright, I'm going to do the same way I did before. I'm going to look at column 1, look at the first number, compare between 2 and 0. I'm going to choose 2 over 0 because 2 is greater than 0. Then I'm going to look at column 2, 0 and 1. I'm going to choose 1 over 0 because 1 is greater than 0. So let me go ahead and circle 2 and circle 1. Now if you look at the rows here, I'm going to choose 1 over 0 for row 1 because 1 is greater than 0. Now if I look at row 2, I'm going to choose 2 over 0 because 2 is greater than 0. I have 2 circles in 2 of these boxes, so I have Nash equilibria. That means there are 2 solutions to this game. The Nash equilibria is shopping, 2-1, and football, which is 1-2. Because there are 2 solutions, this is gonna be not unique. Alright, hope this makes sense. Basically the column and the row approach. Thank you very much.